All right, we're going to start off by doing a bit of review. This was covered in the first semester pre-calc course. Near the end, we're going to go over it again because these skills are absolutely crucial, not just in these purely algebraic expressions, but we'll use these skills in all kinds of expressions. So we start off with some factoring. And we're just going to look at some different scenarios for factoring. The simplest one is factoring out a common factor. This is just using the distributive property, the distributive law, in reverse, kind of undistribute. So in our first example in part A, 6x plus 14y, you might notice that both of those coefficients are even. So I could factor out a 2. So you identify that common factor, you factor it out, you take it out, you open up parentheses, and then you ask yourself, okay, well, you know, what do I multiply by 2 to get 6x? And that is, of course, 3x. Bring down the plus. And then what do we multiply by 2 to get 14y? And that is 7y. When you're done, you want to make sure that you take a look at the expression you've got and make sure that you can't factor it any further. Anytime you're asked to factor something, it always means factor it all the way. This won't break down any further, so that's our final result. Over here in part B, we've got some common factors. Certainly, if we start out with the coefficients, we could take out a 3. And now all three terms have a's and x's, but they're to different powers. So you choose the least power to take out. So we're taking out a 3. Let's see, the power on a should be, we've got a 5, a 3, and a 3, so it'll be a cubed. And for the x's, we're going to take out an x squared because that's the least power. And now we just have to remember our rules of, oops, take out an x squared. We just have to remember our rules of exponents. So what do we multiply by 3a cubed x squared to get 6a to the 5th x squared? Well, I need a 2 to get myself to the 6. To get from a cubed to a to the 5th, I have to multiply that by a squared because we add exponents when we multiply. And then I don't need x's at all, right? I took out an x squared, that is an x squared, so I'm not missing anything. We bring down the minus. Let's move on to this next term. Multiply 3 by 3 to get 9. We don't need any a's this time because I took out an a cubed and that is an a cubed, so we're all set there. And we need an x to the first. Bring down the plus, and then 3a cubed x squared. That is exactly what we took out. So our last term is just a 1. When you're done factoring, you can always check your result. If you multiply this out, you should recover the original expression. Our next scenario is if we is factoring a difference of 2 squares. So if you're subtracting 2 squares, it will always factor in this way here. And you know, you can convince yourself of that. If we multiply out x plus y and x minus y, you will see that we get x squared minus y squared. So there's our x squared, a plus xy, a minus xy, and a minus y squared. So these terms cancel out and we're left with x squared minus y squared. So, you know, if you're going to factor a difference of squares, the first step is recognizing that you have a difference of squares. I'm going to start here in part A. We'll notice that 2x squared and 72 are not squares. But this is a great example to start with because when we are factoring, we always start, you know, it's a good idea to start by seeing if you have any common factors. That will make the rest of it much easier. So you'll note that both of these coefficients are even. So I'm going to take out a 2, and then we have x squared minus 36. Now x squared minus 36, that is a difference of squares. So I'm going to finish this up by factoring that, x plus 6, x minus 6. In part B, x to the fourth minus y to the fourth. These are a difference, this is a difference of squares. They're fourth powers, but they're also squares. Any even power is a square. In fact, I could write this as the square of x squared minus the square of y squared. So this is x squared plus y squared times x squared minus y squared, and then always check to make sure that you're done. We can factor further because of course x squared minus y squared here, our factor on the end, that's a difference of squares. So we're going to factor that. Bringing down the factor x squared plus y squared that we already have. A sum of squares generally does not factor. And that's as far as we can go. Factoring trinomials. So this is just sort of unfoiling an expression. When you factor a trinomial, basically we know that if it's going to factor, not all trinomials factor, but if it's going to factor, we're going to need to start out with this pair of parentheses, a couple pairs of parentheses. And I need the first two terms, right, these two, to multiply out to x squared. I need the last two to multiply out to a positive 10. So to get an x squared, I'll have to multiply an x and an x. And to get a positive 10, I could have, plus 5 plus 2, minus 5 minus 2, plus 10 plus 1. Or minus 10 minus 1. And then I just want to choose the pair that works out so that if I were to FOIL it out, I get a plus 7x in the middle. That pair here is plus 5 plus 2. Factoring a trinomial often, for me, ends up with a little bit of guesswork. But at least the number of choices we have is finite, so at worst, I just have to try a few things before I find what works. And again, not all trinomials will factor. Okay, so next, 8x squared plus 14x plus 3. So, okay, I need to get an 8x squared for my first term. I'm either going to get that by doing, 8x and x, or 4x and 2x. So I have a choice there. Now at the end, 3 is prime, positive 3 is prime, so it's either going to be 3, 1 or negative 3, negative 1, and you'll note that the middle term here is positive, so I'm pretty confident it's going to be plus 3, plus 1. I always try to take advantage of noticing any primes, because if I have a few choices to make there, like that's basically the only choice I can make to get that plus 3, it'll help me out in figuring out this choice that I have to make. I need to get a plus 14x in the middle for my middle term. So if I tried this, like 8x and x, that would be 8x and 3x, and that's 11x, which does not work. You could try, picking the same choice, 8x and x, but just switching them, because where they go matters, right? So this is 24x plus x, and that would give us 25x, so that also doesn't work. So I think we can eliminate 8x and x as an option. It's got to be 4x and 2x, and I think this is the one that'll work, because this gives us plus 12x, and this gives us plus 2x, and that gives us the plus 14x that we are looking for. Always give a look and make sure that you can't factor any further, but there's no common factors to take out of these linear factors, so we're all set there. Factoring by grouping is basically another twist on taking out a common factor. In example 1.4, a lot of the work's been done and the organizing's been done for us, so you'll just note that, look, I'm subtracting two things here. And each of these two things is written as a product, and I could see there's a common factor of x minus 1, so I'm just going to take it out. And then what goes inside, let's see, what do I multiply by x minus 1 to get that first product? Well, I just have to pick up that h, bring down the minus. What do I multiply by x minus 1 to get that second product? And there I need the 2. So there's that expression. Sometimes we have to do the grouping ourselves. So I'll note first, if I just look at, there's no common factor of all 4 terms, but if I look at the first pair of terms, I could take out a 3. And if I take out a 3 from just the first pair, what goes inside the parentheses is x minus y. And now I'll look at the second pair. That has a common factor of a, and what will go inside the parentheses is x minus y. And now we can see that there is a common factor of x minus y between these two terms. So this expression, I'm adding two things together. I'm just adding two products. Each of those products has a common factor of x minus y. I'm going to take that out. And then in the parentheses here, I need to pick up the 3, bring down the plus, and pick up that factor of a. So 3 plus a. All right, and last, our last sort of factoring scenario is a sum and difference of cubes. You'll recall that a difference of squares factors, but a sum of squares does not. Both the sum and difference of cubes will factor, and the rules look pretty similar. So I'll just sort of go over the pattern here. If we have a sum of cubes, I'm going to start by just removing the cubes. So I'll look at the sum of cubes here. The first factor is just x plus y, right? So it's like you take this whole expression, just remove the cubes, x plus y. In the second factor, which is a bigger factor, there are 3 terms. I have 3 terms, each of which I get by multiplying two things together. First an x and an x, then an x and a y, then a y and a y. It always ends with a plus, and this term, that sign rather, always differs from that sign. That pattern continues with the difference of cubes here. You have a small factor and a big factor. The small factor is just x minus y, so remove those cubes. The big factor, you've got these 3 terms. You multiply one of each, x and x, x and y, and a y and a y. It always ends with a plus, and this sign always differs from that sign. The first step in factoring a difference of cubes is to recognize that you've got a difference of cubes. So 8 plus 27x cubed, this is 2 cubed plus, and 27x cubed is the cube of 3x. So this sum of cubes is going to have a little factor and a big factor. So I have 2 plus 3x. The first thing I do is just remove those cubes. Then 2 times 2, 2 squared. Minus, because this sign always differs from this sign, one of each factor, 2 times 3x. And then we always end up on a plus, and then 3x squared. I'm going to just clean up that last factor. So we have 2 plus 3x, 4 minus 6x plus 9x squared. This quadratic, or this trinomial, that you have at the end, that big factor, is usually irreducible. So you could try to factor that further, like unfoil it, but I don't think you'll get anywhere with that one. All right, getting to this last example. There's 2 ways we can look at this. One is to see this as a difference of cubes, because x to the 6 is the cube of x squared, and 64 is the cube of 4. And you could factor it that way, but we'll be able to factor further more easily if we first see this as a difference of squares. So this is the square, x to the 6 is the square of x cubed, and 64 is 8 squared. So this is x cubed plus 8 times x cubed minus 8. Now each of these is, can factor further. We have a sum of cubes and a difference of cubes because 8 is 2 cubed. So the first one we'll factor as x plus 2, and then let's see, the big factor, xx, that's x squared, one of each, 2x minus 2x. That sign always differs from this sign here. And then always a plus, 2 times 2 is 4. The difference of cubes will be x minus 2 times, and then again, the big factor, x times x is x squared plus 2x plus 4. And there it is, factored all the way. If we had started out by viewing this as a difference of cubes up here, it would look like x squared, x squared minus 4 times x squared is x to the 4th, plus 4x squared plus 16. Now, we could see how we'd get the x plus 2, x minus 2 out of this because this is a difference of squares. But I don't know about you, but it's harder for me to see how we'd factor this down to the product of these two. So, even sometimes, these factoring problems can be pretty, a bit challenging, and it can matter how we look at them. And so it's important to keep trying. If it seems like you can't factor something all the way, try rearranging it or seeing it in a different way.